Hi, everybody. My name is Bradley Steinfeld. I'm a software architect with IBM Skills Network at IBM Canada. And today, welcome to my session on getting things done and solving real problems with GenAI. This is an intermediate course, not too tough, and we're going to take about 90 minutes. And it's okay if you don't get through everything. Everything that I'm going to be teaching here is going to be, hands-on, and there's going to be hands-on workshops that we'll get to, and you'll be able to do those, after the session next week or at any point in time. So, yeah, don't worry about finishing everything in 90 minutes. Let's just try and, learn something and have fun. Okay, so for the next 90 minutes that I have you, I'm going to first start with some key concepts and walk through some slides, teach you kind of the main things we want to cover in today's workshop. Then after that, we're going to do a hands-on workshop. I'll start by showing you the environment we're going to use. And this is the Skills Network learning environment that we're going to use, and we're going to use a tool called Cloud IDE. What you really need to take away from this is that you don't need to install or download anything. This is entirely cloud-based. I would definitely recommend using a laptop or desktop. This might be kind of tricky on mobile, but you're definitely willing to try and follow along. And even if you just want to, follow along and watching me do some of it, that's totally fine as well. So then we'll do, after I give a quick demo and show you the lab environment, you'll be left on your own for a little bit, maybe about 20 minutes, 30 minutes, where I'll be available to answer any questions if you might have. We'll finish up with some quick takeaways and a quick Q&A where I'll answer a few more questions if you have any. So to start, have you ever tried asking an LLM, a simple question, or even talk to someone else who's, talked with ChatGPT and asked the simple question, something like this, how many R's are in the word strawberry? And this is kind of the famous example. It's mostly fixed in the newer models now, but still, the idea here is that it's a very simple question for a human to answer. Yet the LLMs often get something like this and a whole class of problems wrong. And, oftentimes people will just dismiss this and say, these LLMs, they're worthless. They can't even answer a simple question. But really, that is just a misconception of, what these LLMs are and how they work and how to extract the most value out of them. So to start, we're going to just talk about some of these misconceptions that people have with LLMs and GenAI. Then we'll lead into some of the challenges with actually using LLMs, and especially in a more complicated way. Then we'll talk about the power of LLMs and all the things that we can do with them. And then we'll dig into the meat and potatoes, if you will, of this session and talk about LangGraph, which is the actual tool we're going to use to accomplish really moving beyond simple chatbots and simple LLM use cases and make something much more powerful. We'll build whole workflows that use AI within them to get things done. And then finally, we'll talk about just some tools and techniques to make sure we get the best out of our time and the best out of our code. So starting with some misconceptions, it's LLMs are unreliable. They're just good for creating simple chatbots. A chatbot that knows about cars, a chatbot that knows about this, or maybe just summarizing PDF documents or summarizing emails. And while LLMs are actually great at all of these things, or rather the chatbots and the summarizing, not necessarily being unreliable, they can do a heck of a lot more. And I feel oftentimes people have a bad experience and get a bad taste in their mouth with LLMs and just forget to look deeper. So we're going to try and look a little bit deeper. And if you are one of the people who've experienced this, and I know I am, who ask a simple question which the LLM should be able to answer, or you think it should, and it can't, you have to really try and break it down and understand why. So ultimately, these misconceptions stem from not knowing how to leverage these LLMs effectively, not really from the LLMs themselves. So it's not the tool that's lacking. It's really how we're using that tool. So let's talk about some of the challenges with using LLMs and kind of the challenges ultimately oftentimes lead to those misconceptions. So first, and you can see there's 7 different hurdles that we're going to go over. First one is just model selection, choosing the right model. Now, this is actually something I find very interesting. It's a whole it's a whole workshop in and upon itself. To that point, we actually have a whole workshop, a whole guided project which covers just this topic and digs deep into it. I'll probably link out to it at the end just in case anyone's interested. So if I forget, feel free to ask me in chat and I will give you the link to that other project as well. But choosing the right project, choosing the right model is one of the most important things you want to, or you're going to do when you're using LLMs. Choosing the right model affects the quality of the results, the speed, the cost, and really everything else to do with what you're going to get. And if you choose the wrong model, you've pretty much already lost the game before you've even started. I'll also stress that choosing the right model isn't something you want to do once. This is an ongoing practice. You've probably seen models are coming out all the time. It used to be, a model every year, then, on the order of a few months, then months. Now they're coming out almost daily, it seems. And I don't expect that to slow down. So, choosing the right model is something you need to do not just once, but many times. So you really need to, have an infrastructure in place, especially if you're using LLMs a lot within your application or within your code, to, consistently test against your specific code and the things you want to solve, all the different models. And it's important to know that different models have different strengths. And I'm sure you've seen different benchmarks. This one can answer this type of PhD level questions this well, these math questions, do code, so on and so forth. And while those are useful, you really want to make sure that you test the models against your actual problems and the problems you want to solve, because it does make a difference. Next, you need to prompt these models correctly. So prompting is just the actual, natural language you send to these models, the input, which it then chugs on to give you the output. And ultimately, this is, sending natural language as the kind of like the programming code. And it's, if you don't send the right code or you don't create the right natural language, you're not going to get the most out of your model. And this actually has a few different faces to it. For one, different models have different syntaxes that they use. For instance, Llama 2 and Llama 3 actually have very different syntaxes. The way that you define what your system message is, what the AI messages are, what the user messages are, is a completely different way of doing it in Llama 2 and Llama 3. And if you try and upgrade to Llama 3 without understanding that and crafting the correct prompts, you're just going to likely get worse results than you got in Llama 2. However, just by simply using the right syntaxes within your prompts, it's going to make things, significantly better and faster and cheaper. Now, on top of that, there's a whole bunch of techniques regarding prompt engineering. In fact, we have also a whole course on, learning how to do prompt engineering, various techniques, chain of thought, so on and so forth. So, building a good prompt is probably one of the most important things you'll do aside from actually choosing the right model. Next, it's quite difficult when you have, a complex workflow to include LLMs within it. And especially because you'll need to, maintain the workflow, know where you are in it, keep track of state. It's not something that's trivial to do. And when you start working with LLMs, which, you might feel is non-deterministic, who knows what you're going to get back from it. It just makes this even more difficult and even more complicated. So this is actually the main the main area that we're going to delve into within this session on, creating complex workflows and, making them working with them in a way that's really great for both the developers as well as the architects and stakeholders and everyone else on the project. Next, just to reiterate, making sure that, LLMs are actually return reliable results and are deterministic can be something very hard to do. And again, there's multiple ways to make sure that LLMs are deterministic. Now, you don't always necessarily want deterministic output. Sometimes you want it to be creative and to spit out, stuff that is different every single time, and that's fine. But especially when we're talking about, creating complicated workflows, generally, in most cases, we want the LLM to be very deterministic and to kind of return what we want it to return in the right format. And there's a few different things. This touches on prompt engineering as well. It also touches on things like using the right hyperparameters. So hyperparameters are pretty much, the configuration that you pass the LLM when you do inference. So one of the most important ones here would be temperature, which is a value from 0 to 1. And pretty much, simply put, choosing a number closer to 0, you're going to get a much more deterministic result that's going to give you the same answer every single time. Yet choosing something closer to 1, that's going to make sure that your answer is a lot more creative. So it's going to do something different, so something a little bit, less deterministic every single time. So prompt engineering, choosing the right hyperparameters, so on and so forth. You really need to invest, a good deal of work and effort to make sure that your LLMs are deterministic. But once you understand, how they work, you can definitely achieve this. This is 100% achievable. Next, scaling up LLMs for, real world use. It's one thing to, run a bunch of stuff on your laptop for one user on a test application where, you don't care too much about the speed, you don't care too much about rate limits, you don't care too much about cost. But, ramping that up to an application that's going to be used by, tens of people, hundreds, thousands, potentially millions or beyond, can be quite a difficult problem to solve, and really makes each of the previous hurdles that much more important, especially model selection, because ultimately, even though something works, it might not work at scale, and even if it does work at scale, it might cost you millions of dollars. So you really need to be careful in scaling these applications. It is kind of like an art, and something which you need to invest some time in as well. Now, this means sometimes we're going to use a more powerful model and have one very big invocation of it and get back a single result. Other times it might mean breaking that single big problem down into multiple cheaper model calls. It really depends on your problem and what you want to solve. Next, just simply integrating LLMs into a code base that doesn't use LLMs can also just be complicated. It adds, a different type of complexity to your code, new packages, so on and so forth. So this is something which can often become a hurdle. So you want to make sure that when you integrate LLMs into your code, to be a little bit thoughtful in how you do it and choose some best practices up front. So that could mean, things like using open source libraries like LangGraph, which kind of let you don't force you to choose, for example, among other things that it does, don't force you to choose a specific vendor with your models or a specific model. It will let you down the line, switch if you need to switch from, IBM to OpenAI and back, or whatever it might be. Using a tools and having the right architecture from the get-go will definitely make sure that you have a good time. And last but least, I just want to focus on this. I think this is really important to remember, that you got to choose the right tool for the right job. Now, LLMs can solve a lot of problems, but that doesn't mean we should use them to solve all of the problems that they can solve. So one silly example would be you want to add 1 plus 1. Now, I can definitely take 1 plus 1, pass this to an LLM, and get the right answer of 2 back and use that. But there's really no point to do this. I think it's pretty easy to see that this would not be the right thing to do. Just, using whatever programming language you're using and just typing 1 plus 1 is probably the better thing to do in terms of speed, cost, performance, and really every metric you want to consider. So obviously not every use case is going to be as simple as this, but you might get into a case, for instance, where you want to do work with time zones, and you think, oh, it's easy. Let me just send this time and say, hey, this time's in Eastern, convert it to Pacific time. It might seem that's a good idea, and it might work just fine in LLM. Yet likely it's probably a better thing just to use a library for, again, a whole variety of reasons. So again, really understand the problems you're trying to solve, and really understand, is an LLM going to be the right tool for this job? Okay, now that we're over the challenges, let's start getting into the fun stuff and start looking at the power of LLMs and what we can really accomplish with them. So first, as I kind of alluded to before, LLMs let us effectively code with English or whatever language you want to use, so a natural language. And it pretty much turns this natural language into instructions that we'll get an output from. So effectively, we're now coding in English or whatever language you want to use. And this can be very powerful. It makes a lot of things much more easier or much more easy. And it lets us do complex reasoning. We can generate creative content with just a few lines of prompting. with multimodal capabilities, we can generate images, parse images, understand nuanced instructions, and really we can break down really complicated problems, which we would need, specific libraries, lots of logic and thinking and coding, and kind of solve it in just some, simple English that anyone, even a junior developer, can create with a little bit of work. It's an extremely powerful tool. And for instance, within this workshop specifically, we're going to be using the multimodal capabilities of Llama 3.2 Vision. And I'll cover this later again, so don't worry about remembering this. But one thing is we're going to take an image of a street view camera and pretty much determine how many people are in that image using the LLM. And now this is something which I've done a lot of computer vision before. Problems like this, would require us to, train models, pass in a whole bunch of pictures of what people look like, a whole bunch of pictures of what not people look like, label our data, train models, and, it would be a very complicated and long process. And now we can just kind of answer or do this problem with simply just sending an image and typing the instructions, the English instructions of how many people are in this picture, answer in an integer. And again, I'm making it a little bit simpler than it is, but in actuality, it's not much more difficult or more complicated than that. And this becomes even more valuable when you realize how easy it is to adapt this. So for instance, if now I wanted to change using before LLMs, using computer vision to say, okay, let's count how many dogs and cats are in this image, I would now need to retrain this model, get a whole bunch of images of dogs, images of cats, retrain the model, deploy it again. Yet with LLMs, I just simply change that English instruction to change how many people to how many cats and dogs. So this applies in a lot of other use cases, but hopefully this example makes a little bit of sense to you on the true power that these LLMs can bring you beyond just, again, summarizing content or acting as a chatbot. So I want to reinforce, though, that LLMs really unlock their full potential when you combine them, with multiple LLMs. So you have, multiple models calling each other. Also combine them with, other APIs to read and write data to external data sources, connecting to databases, so on and so forth. And when you wire all of these things together, that's what truly, elevates your LLM game, your AI game to the next level, because it really lets you do some really novel, creative, and powerful things. So that said, now that we're connecting our AI with all these different things, as I mentioned, is one of the big hurdles and difficulties of implementing LLMs is that our code becomes quite hard to maintain, debug, and extend. We're throwing a whole bunch of LLM calls in here. There's a whole bunch of logic, and it can become a mess very easily. So the solution that I'm going to propose, and there are other tools out there, especially I can see in the next coming weeks and months, this is going to be a very hot topic with a lot of agentic things coming around. So keep your eyes open. But for now, a really great open source solution created by the LangGraph team, which is again one of the most popular open source libraries for working with LLMs and other GenAI models. They have a tool called LangGraph. So specifically, this workshop uses JavaScript, so we're going to use langgraph.js, but it's also available in Python, and I believe it was originally created in Python. So what is LangGraph? So it ultimately is just a library, but it's a library that lets us create modular workflows and to do so in a very simple and structured manner. So it's going to really break down our, all this code that we have and the complexity of our code into a bunch of, well-defined nodes and edges. And this really will simplify integrating these LLMs into our applications. It'll make things much, much easier for the developers to really wire things together. And more importantly, not do the initial wiring, but, when you want to, change something along the way, pulling out one piece and switching it is going to be, arguably trivial with LangGraph, whereas it would be, a really complicated process, digging into the code, changing if conditions, so on and so forth. And then the other bonus kind of feature that you get out of LangGraph is it gives you the easy to follow code, but also the visualizations of your workflows, which is an actual image. And I'll show you some of those visualizations of these graphs that we're going to create and these workflows we're going to create. but it becomes a very useful and valuable tool, not only for the developers to be able to visualize these workflows and how the data and the state is going to flow through them, but also for other people on the team, whether they're other developers who are going to work on this or even stakeholders, so they can understand at a high level how the process is going to work. So, traditional, this is, very pared down, simple example. But traditionally, when we want to implement LLMs in our code, we'll do something like this. We'll have a function called process data here. It'll take some input in, whatever format it might be. It's going to need to pre-process this input. Now, this pre-processing, for the most part, is just, taking that input and turning it into a prompt instruction and figuring out what our prompt is. But it can also be things like, determining, for instance, other, the hyperparameters and other different configurations, which model we want to use, so on and so forth. And then we invoke the model. So that just actually sends this pre-processed information, our prompt instruction, to the model, sends it to the LLM, and we get some output back. Now with that output, we're going to post-process it, figure out the different values from it, and simply return. And what I'll say first of all is, if you're just implementing something extremely simple, like you just want to start using LLMs, do a simple call to an LLM, get a string back, and just use that string and plop it on a website and keep it simple, this is the way to go. You don't need to do anything more complicated than this. And adding LangGraph into your code is just going to be at this point a waste of time. However, if you are planning on doing complex workflows, if you are really know that even though you're going to start with this, you're moving to more complexities in the future, that's when you want to start considering and implementing LangGraph. And LangGraph will pretty much change that, just traditional code with a bunch of, nests and if conditions to like I said, a bunch of nodes and edges. So for instance, here, we can see that this is a workflow. It starts at the top. It ends at the bottom with step log results. Each of the rectangles is a node, so that ultimately will map to a function of code that's going to run. This can be calling an LLM. This could be reading from a database, writing to an API, running just some basic JavaScript, whatever you want it to be. The solid lines are pretty much paths to take after you finished running that node. And you can see right at the top, we run two things after our get latest data. We run two things in parallel. So LangGraph lets us do things in parallel as well in a very, very simplistic way without having to, really worry about what the code looks like. The dotted lines are conditionals. So you can see, for instance, after this step, analyze stock, depending on how we analyze the stock, it can either notify the quality team, check the stock health, do various things. And these edges as well are functions in our code that pretty much will return, based on the current state of our graph and, different aspects, what node to move to next. And the last thing I'll just mention, and this is kind of a spoiler for later, but this little interrupt equals before in step proceed with operations is our human in the loop. And at least for now, we don't necessarily trust, while these LLMs and GenAI systems are great, we might not want to trust them with actually, pushing the big red button, whether that means, sending money, making a real sale, launching a rocket, whatever it might be. We generally, at this point in time, still, want a human in the loop. So the AI will do all the work, figure out, I want to buy this stock. And this interrupt before means before we actually proceed, we need a human, a real person to come in and pretty much, check the state, check the data, check what the AI wants to do, and either say, check mark, yes, proceed, or X, no, stop here, don't proceed. Or alternatively say, yes, proceed, but, modify the data in some way. I only want to buy 10 shares rather than what AI is suggesting of 30 shares. And at least for this point in time, and let's hope it lasts for a while, us humans are still important and required in this. So that's another important thing which you get, again, for free with this LangGraph library, the ability to have these interrupts or these breakpoints within our graph where we actually wait for a human to come in and make the graph resume. So Once again, what we get out of LangGraph is we get modularity, where we break down all of the different tasks and functions into nodes and edges. This gives us a lot of flexibility because if we want to change the code, for instance, there's a new service we want to use to get stock prices. We simply can just take that single node, understand what the inputs are and the outputs are, and replace that one node without having to understand any of the other logic of the entire graph or the rest of the application. This can be really powerful because we can get, even an intern or a junior developer who knows nothing about the code base and just say, hey, here's one simple node. This is what the input is. We expect this format of output. Use this new service and go to town. And that person is able to be, productive right from day one. You have conditional logic, and as I mentioned, we get human in the loop, which is, very important part of these workflows, so that we can get, us humans still part of it to approve if things should proceed or not. So, this modularity is very important. It really separates our duties. It simplifies the collaboration. And ultimately, this leads to, faster development. We've been using on our team LangGraph for a whole bunch of projects, and it's really been, it might be a little bit to get started up front. So the cost up front is a little bit. But once you have the infrastructure in place and the architecture of LangGraph in place, it's amazing. It really is extremely valuable and really shines and lets us, whether it's interns working on the code, whether it's understanding the code from a high level and the different bits of it, it becomes a huge piece of value. So again, LangGraph lets us focus on the individual components without getting lost in the bigger picture. But it also lets us focus on the big picture without necessarily getting overwhelmed by the individual components. And that's by looking at the graph without actually, needing to see any of the code at all. So it really is good for the developers, it's good for the stakeholders and everyone in between. So, with LangGraph, everyone can be a specialist without needing to be a generalist. Now, one little bit more before we get to the workshop and the demos. So, you can code things simply. You can make things really complex, but I just want to really stress that use the right tool for the right job. Don't use a sledgehammer to crack a nut. So I've said it before, but I'll reiterate it. Just because you can use LangGraph, just because you can use an LLM, it doesn't mean you should. Really understand what your problem is and your, whether it's an application, a service, whatever it might be, what the problem you are trying to solve is. And then from that, it'll kind of lead you to the right, whether you should use LLMs at all and how to use them and which models to use, so on and so forth. So really evaluate the complexity of your project before you decide on the tools. Now, this isn't always possible, but do your best, reasonably speaking. Again, we need deterministic workflows. The more nodes you have, I guess I'd like to think that a graph in LangGraph is only as strong as the weakest node, meaning if you have a node in the middle that calls an LLM in a way that's not reliable, that's not deterministic, and it breaks down, the whole graph pretty much breaks down. Now, again, there are cases where you do want non-determinism, but in general, we really need things to be deterministic, and we need to think about this right up front just to ensure that our workflows go smoothly and everything processes nicely. And ultimately, if we don't have deterministic processes, for the most part, LLMs just might seem unreliable, and it really will just reinforce those misconceptions that LLMs are only good for chatbots and summarizing documents. So let's keep things structured, consistent, and predictable. So deterministic workflows really turn our AI potential into a reliable reality. Now let's introduce Tech Cafe. So Tech Cafe is going to be the fictitious application / coffee shop that we're going to be working on, that you're going to be working on within this workshop. So it's just a fictional coffee shop which just wants to start innovating with AI. I'll say right now, it's a silly example. Just take it at face value. This is really here to help teach, as a practical example, to help teach, LangGraph, using Llama, and to teach all the different skills we're going to cover. But ultimately, they have two challenges, this fictional coffee shop Tech Cafe. Number one, they want to start using AI to personalize their customer experiences more. So right now, which you'll see when someone orders a coffee, it just says their name on it. we want to do something a little bit more fun that can maybe use an LLM to create a sentence based on their name and the order they make, just to be a little bit more personable. And then a little bit more complicated, we want to adjust the prices of our coffees based on the foot traffic outside. So this is what I was alluding to before. We're going to use Llama 3.2 Vision to pretty much take an image, pass it to our LLM, and determine how many people are in this image. And depending on the answer we get back, use that to dynamically adjust the prices of our coffee. The idea being, for example, a Taylor Swift concert just ends and there's, thousands of people flooding the street. It might be a good idea to have a special sale right away to, get those customers in the door. Again, it's a very contrived example, but just bear with it. So this is briefly what Tech Cafe looks like. It's a very simple application. I'll show you a little bit slower. I also don't know how well this is coming through, but the idea is you choose a coffee, you give it your name, you choose your customizations, how much cream, sugar, and then it says, thank you, Bradley, thank you, your name, and gives you your coffee. I'll go a little bit slower in a second. Now the three things, so there's three different major sections to this workshop that you're going to do. The first is just a very, very basic introductory step to just generate that personalized message. It's just calling out to the LLM. It's kind of one of those examples that I would not use LangGraph for, but is a good demonstration of just how it works and how we can integrate it into our application. Next, we're going to use the Llama 3.2 Vision, passing it images and determine our foot traffic. And then finally, the third part of this lab is actually implementing human in the loop. So ultimately, we're going to be creating these three different graphs. So you can see the first one on the left, the generate message. It's very simple. There's really only one node to it. There's no reason to use LangGraph, but again, it's a good example. Then the next one gets a little bit more complicated. You can see first it'll run the step get latest image, which gets an image from our webcam, and then run step scan image, which is calling our LLM. And then finally, when we want to start doing human in the loop, I won't go over each step, but you can see the step right before end is step start sale, which pretty much before we start the sale, we have an interrupt before, which means a human is going to come in and there's a little simple web page for this where they can pretty much click a check mark or click an X to say, yes, let's start the sale, or no, let's not start the sale. Okay, so we made it. So if everyone can now go to this link, it's ibm.biz/tx-solve. I believe this is going to go into the chat as well, likely pinned. You can also scan this QR code or go to cognitiveclass.ai and search for Get Things Done and Solve Real Problems with GenAI. So we're going to use cognitiveclass.ai as the platform, as the learning platform for this workshop. So it's completely free. You don't need to use any credit cards or pay anything. Moreover, I'll just reiterate that within the lab, you don't need to install or do anything. Chrome probably works the best as a browser, but you don't need a cloud account. You don't need to register for anything else or any external services. You'll only likely need to register for cognitiveclass.ai using whatever email address you want. So I'll probably give everyone now a few minutes to log on, register, and then I'll show you the next steps on how to get into the project, and I'll show you very briefly the start of the project and how that looks. Okay, while we're waiting, I can see we have a few questions. So I think we have two from Daryl, so I'll read these both and maybe I can hopefully answer them in one go. So first is, what are the evaluation methodologies, or how do we measure that one generation is better than the other apart from human evaluation? Now, I assume that is regarding how to choose the right model and how do we evaluate which one's better than another. And then he continues, if we're using multiple LLM models in the pipeline, won't that consume a lot of GPU, which would be inefficient or slower devices at inference. So I think that's mainly saying, if how can multiple LLM calls be, less resources than a single LLM call? Now, I'll answer these one at a time. So to start, evaluation methodologies, there are a number of different ones. So I will say we use a tool called Prompt Foo. It's probably the most or one of the most popular tools for comparing LLMs, and there are a number of them. It's open source. It's quite good, and it pretty much builds up these tests that are repeatable, and you can very easily define what criteria and evaluation methodologies you want to use. So they have very simple ones that just say, given this prompt, I expect exactly this value, or I expect JSON that requires a value that's between 5 and 10, or it expects this range of values. There's a whole bunch, and in the same way, normal like unit test frameworks have all different types of assertions. It has a lot of those. It also has, I think they're called LLM matrix evaluations, which actually will call out to an LLM to do the evaluation itself. So for instance, if you want something to be humorous, what you can do is, pass the prompt to the variety of models and say, generate a humorous phrase, blah, 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 get the results, and then take that answer and then feed it to another LLM to say, how humorous is this? Rate this from 0 to 100 on how humorous it is. And then that'll let you say, okay, which one's the most humorous? Obviously, that subsequent LLM, you have to have faith in that it's going to evaluate correctly. So things aren't trivial, but you have a lot of flexibility in that regard. Now, I'll say the most important thing here is really understanding what your specific problem is, because again, there are tons of benchmarks already available, and you could just kind of be naive and just choose the benchmarks that have the highest bars, or you try and be a little bit more clever, the highest bars in the the areas you care about the most. But I would stress that what you really want to do is understand the very specific, all of the ways that you're using AI and LLMs within your application, and create test cases for all of those specific use cases, meaning having prompt instructions very similar, if not identical, to the way they're going to be within your code base. And then you have to really understand, what is this trying to solve? Is this getting an integer? Let's test that it's an integer. Is it getting a paragraph that needs to be humorous? Let's test that. So you'll generally have, multiple evaluations, and yeah, it really depends on your problem. But hopefully that goes some way to answer your first question, Daryl. Your next one, multiple LLMs want to consume a lot of GPU. Now, this really just depends on the models. So, we can go extreme, and I'll say, there's O1 Pro, so OpenAI's O1 Pro. I believe you only have access if you pay, $200 a month. It's you ask a question, it can take 15 minutes to come back with an answer because it thinks and it iterates. You actually pay for all of that thinking time, and that's going to take a whole lot of resources to get you an answer, but you're going to get a good answer. However, if you use something like Granite, it's going to cost 1/10,000th of the price, probably return 1,000 times faster. So even if you have to call Granite 10 times to get the same reliability and same quality of result, 10 times is still going to be probably return still 1,000 times faster and 1,000 times cheaper. So it obviously 100% depends on the problem. There are some problems which Granite is not going to solve, or not be able to solve as good, no matter how many times you call it, and so on and so forth. So it really depends on the problem and your use case, but it definitely can make sense. And also, in this regard, another important thing to keep track, or to keep in mind, is all the other different parameters, I guess, if you will, of these models. So context window is a very important one. Context window being how long my prompts can be, how long that natural language instruction can be to the LLM. And now if sometimes if we'll have to choose a model just because this is a problem which can't be broken up easily, or we don't want to implement something like RAG because that's too complicated. Whatever it is, it really depends on your solution. And the models have all different knobs. It's not just quality, price, speed. It's other factors as well. And sometimes you're just going to be stuck with the model because that's what the company you're working for is forcing you to use. So yeah, choosing the right model is super important. I definitely recommend you, and I'll put it up later, taking the other workshop or guided project we have on that. That said, I believe it's Joviera or Joviera. I'll try and get to your question later. I'm going to continue on for now. So you should land up on a page like this. Now it might say enroll now because you're likely not enrolled. You can click enroll now or go to class. That should bring you to a page like this. It might bring you to the root of it, in which case just click get started. So for example, if you see something like this, simply just click get started. And you'll get to a page like this. Scroll to the bottom and there's a button that's called launch your project in Cloud IDE. You click it, then click OK. And that's going to load the lab environment for us. It's going to take a couple minutes. I believe mine's already warmed up, so mine probably is going to load a little bit faster, but it shouldn't take much longer than a minute, if not quicker than that. And this will bring you into the lab environment. So again, I just want to really stress that you don't have to finish this today. You don't have to finish it by 5 o'clock when the session ends. You have this available to you, I won't say forever, but knock on wood, forever. Definitely, later today, definitely in a couple months from now. It's free. You have access to it. So yeah, just go at your own speed. Please feel free to play around if you find something interesting. Just play around with prompting in different ways. I think that's probably one of the best ways you can actually learn. Build up different graphs, take advantage of the environment, and don't feel stressed that you have to finish anything. All of the instructions and all of this environment will be available to you now and in the future as well. So the environment, it pretty much has two main sections. The instructions on the left. So again, you have me here. So I've already talked about some of this stuff. But again, you can go over it again. It's all available here. It will walk you through the entire project. So the instructions on the left, if you see at the upper left, there's a little hamburger button. You can click that and this shows you, a table of contents. There's 20 pages. You can click to whichever page you want. Also, you can just click these little rectangles at the top. It does the same thing. On the right, we have our tool. So our tool here is Cloud IDE. Now this is like a VS Code online pretty much. So we have a whole bunch of different features here, but we have a file system. So if you click the little two file folders at the upper left, we can open our file explorer, which once I start creating files, I'll look at those files briefly with you. We also have a terminal. So if you click, terminal, new terminal, you get a terminal where you can run code, which we're going to do as well. I'll point out a few other little features, but for now, I'm just going to start walking through. So before we actually get to working with Tech Cafe, there's a very, very basic Hello World example, and I'm going to go through that full Hello World example with you. And then after that, I'm going to stop sharing and kind of leave you all to your own devices, be available to answer any questions. And then again, probably 15 minutes to 5, so maybe roughly around half an hour from now, I'll come back and do a quick wrap up and Q&A if anyone has any final questions. So this is an introduction. It kind of talks about the learning objectives. I'm going to skip over it because I've kind of covered most of this already. Again, this is introducing Tech Cafe. We covered this in the slides, so I'll go to the next page. Now, first thing we're going to do is just set up our infrastructure. So, or rather set up our file structure. So the first thing we want to do is we see this code block here, and what it's going to do is going to git clone this repository to get some code, and then cd to that folder. So you're more than welcome to traditionally copy and paste it, but we have these two buttons here. So the one on the right is the copy button. So you can, you're more than welcome to copy and paste it in the terminal. But to make your life easy, you can click the > button. And what this will do is, automatically run the code in the terminal. So you can see I clicked it and it ran the git clone. And then Let me actually zoom in just a little bit, so make it hopefully a little bit easier for everyone to see. And it also, in the File Explorer, I now have this example project folder that I just cloned. So the instructions explain this project hierarchy and the structure of it, but I'll go very, very quickly go over what you get. So first you get a graphs folder. So this is just pretty much PNG files, images of what our graphs look like. I've kind of showed you them already in the slides, but you're more than welcome to right click and download them and view them. Part 0, part 1, and part 2, they're checkpoints in the code. So again, I'll just reiterate once more. Please do play around and mess up the code. If you break the code and the application's broken and you don't know how to fix it, that's what these folders are for. You can just simply go to and there are different parts within the project. Part 0 is identical to the start of the project. Part 1 is in the middle, and I believe part 2 is right before human in the loop. So right before the last bit. So know that these exist. So if you ever mess up your environment, you can continue off by using these. Most of the main code is in this source folder, where we define it's an Express application. It's using TypeScript, so .ts files. And the main point of this workshop and project is not about learning, how to create a web app. It's not about Express. So I'm not going to dig too much into, the files that exist here and how they're structured. By all means, look yourself. You have full access to them. Play around. Again, totally a good thing to do, but not the focus. So I'm not going to spend too much time on them. And nor is the instructions going to delve too much into it. Again, we have some basic information on, where things are, and that's kind of it. So now that we're in this file, we want to install all of our dependencies. So this is going to be Express, which is, the application server. We're going to install TypeScript and some other dependencies. And now that all of the dependencies are installed, we're going to run our application. So this is just going to run the basic tech cafe. So you can click, once again, this execute button. And in a few seconds, you'll see it starting the server. And eventually, you'll see server is running at localhost 3000. Now, I just want to make very clear, you can't just run this in your browser. If you try and do that, like I just did, I think you'll just get an empty page or it won't load. Hopefully I'm not running anything locally on 3000, because ultimately we're running this within the cloud. We're running this application, this tech cafe, within the Skills Network environment on the cloud, not on your local computer. So in order to access it, there's two main ways. Number one, within the instructions, we're usually going to, whenever we ask you to start the application, there's a simple button. In this case, is Open Tech Cafe app. You click it. And what it will do is just right within Cloud IDE, it's going to open the application up. Now, if for whatever reason, maybe your browser has JavaScript disabled or a bug in our code, whatever it might be, there is another way to access this. So if you look at the left bar here of Cloud IDE, there's a little icon for our Skills Network toolbox. Now it's the same as the upper left. It's a little like tree with circles surrounded by two concentric circles. You click it and there's a launch application button. If you click that, you simply have to enter the port into this input box. So you can see here it's localhost 3000. So we'll enter in the number 3000, and then we can simply click the Your Application button or this external launch. Now these will both open up the application. Your Application button, which I recommend you use, will open it up right within Cloud IDE, which will pretty much keep you in context, keep your instructions close by. But if you, for whatever reason, want to open it up in a separate tab, you're more than welcome to click the other button. So I'll click the Your Application button, and you can see it opens up Tech Cafe. Now let me give a quick but slightly slower than the GIF I had in the screenshot. So this is our application. You'll see we can buy an espresso, a latte, a cappuccino, and an Americano. They each have their respective prices. Now, there's no real money exchange. It's all pretend. But you can at least see that this is the way it looks. Let's choose, for instance, let's buy a cappuccino. So I'll click Purchase. The first thing it's going to ask me is what's my name. I'll put Bradley. Then it's going to ask me to customize my drink. So how many creams, milks, sugars, sweeteners. So I'll say, I want tons of cream and tons of milk. with nothing else and whipped cream. I just want the, the creamy white things, I guess. Confirm my customization, and there you go. It says thank you, followed by my name. Your cappuccino is ready. I get my cappuccino. So let's pretend that this is me getting this in real life. And then it just reiterates the customizations I told. And you can see from the console logs as well in the terminal, we log out, what the order was. So the first thing, as I mentioned, that we're going to want to do after this Hello World example I'll show is to pretty much update this page rather than just saying thank you, your name, your cappuccino is ready. We want to have something a little bit more personal. So we're going to pretty much call out to an LLM, pass the LLM our name, the type of coffee, and the different customizations. And it's going to use that to just be creative. In this case, one of those cases where we don't care too much about determinism. Be creative and just generate, a short sentence, to say, have a great day, a creamy, milky day in this case, because I got a lot of creams and milks. So that's going to be the first thing we're going to want to alter. So that's our Tech Cafe application. That's pretty much all it does right now. It's very simple. Now let's stop it. So go back to the terminal and you can just, press Control C, and that will end it and stop the service. Again, there's this short demo in here. So if you forget about this, the instructions will guide you through it. And if we continue through our instructions, now the next page talks about LangGraph. This probably looks familiar because we've already talked about it. So I'll move on. And now we have create a simple Hello World graph with LangGraph. So this is just a very basic demonstration. Before we actually start integrating with Tech Cafe, let's just first see very briefly, and I'll walk you through what LangChain code looks like. So the first step is to install LangChain and LangGraph. So we're going to run this npm install. So I'll run that. It should install relatively quickly. And then what we're going to want to do is create a new file. So you're more than welcome to open up the Explorer, right-click, choose New File. But we have this nice little button here in the instructions called Open Hello World Graph.ts in IDE. If you simply click that, it'll create the file for you and open it up for you. And then we can start adding code into it. So the first thing we're going to want to do in this file is import LangGraph. So let me zoom in just a little bit more as well. So you can see we're importing 4 things from LangGraph. We're importing the annotation. So this annotation is going to define, what our state's going to look like. So as we go through this graph in LangGraph, it's going to maintain our state, which we have full control over what it looks like. In this case, we're creating a very, trivial, silly hello world example, and it's going to have 3 things in the state. It's going to have a greeting, which in this case is hello. It's going to have a recipient. In our case, it's going to be world. And then it's going to have the final message, which is just going to be, hello world, putting those 2 things together. So our annotation, which we'll see very quickly, or if you're keen, you'll notice it here on the left. I'll get to it next. That's what the annotation defines. The state graph is the class which helps us actually define what the graph is going to look like. So that's pretty much what the nodes are, the edges are, and how those all fit together. Next, start and end are just constants for defining our graph's start and our graph's end node. Okay, with everything imported, now let's define our annotation. So this is the state I was just talking about. Again, I just click the copy button, pasted it in. You'll see I create this hello world annotation. It calls annotation.root and has 3 different things in it. Our greeting, which is a string, our recipient, which is a string, and our message, which is a string. Very simple. You can get, a heck of a lot more complicated, have different data types. We'll do a few different ones. We don't get too crazy within this project, but, we do cover stuff that's, a lot more complicated than they're a little bit more complicated than this. Now that we have our state annotation defined, so what our state's going to kind of look like, we define pretty much what our nodes are. So 3 functions here. We have create greeting, set recipient, and combine message. And these are pretty much going to define the 3 nodes in our graph, or the 3 main nodes in our graph other than the start and the end node. Create greeting. What it's going to do is it's going to set our state.greeting. So once again, this greeting property of our state Just going to hard code it to hello. And then it's going to log step 1 created greeting and return the state. I'll just say here, all of these nodes, it's very important to return the state, because the whole idea is you're going to get some input state, you know the fields it's supposed to have, you know what to expect. You run some code, whether this is, some hard-coded stuff like we have right here, or this could be calling a database, an API, an LLM, whatever it might be. You update the state and then return the state back. If you don't return the state back, we pretty much lose our entire state and it wipes the state. So always important for each of these nodes to return the state. So after our create greeting, we have set recipient. Again, it just sets the state.recipient. So the recipient string in our states to world, and then logs step 2 set recipient. And then finally, we set our message to just state.greeting. So in this case, it's going to be hello, comma, state.recipient, which is world. So it's just going to be hello, comma, world, exclamation mark. And then it'll log that the message has been combined. Now that we have our functions, let's go ahead and actually define our graph and what that's going to look like by using the state graph class. So we create a new state graph. We pass in the hello world annotation, which pretty much tells this graph to say, hey, throughout this graph, we're going to use this annotation. Now, this is a very basic example. There's a lot more you can do here. There's graphs, there's subgraphs, and complicated things you can do with LangGraph, but just as a simple state, this is what most of the graphs are at a high level going to look like. You create your new state, passing it what your state graph, passing it what the state's going to look like with the annotation. You first then define what your nodes are. So you can see here, I define this create greeting node, which just maps to our create greeting function, and it's pretty much mapping a string, naming that node and mapping it to a function. So these are just the 3 functions: create greeting, set recipient, and combine message. So this just defines our nodes. And then after we define our nodes, we simply define all of our edges. So it's pretty simple. We're going to start, and start is going to go first to create greeting, and then create greeting is going to go to set recipient, and then set recipient is going to go to combine message, and then after we've done combine message, we're done. And then finally, we're going to compile this graph into, I believe it's a compiled state graph is the class. And this is, now we have this graph, which we can, call multiple times and reuse over and over and over again, if we so please. So now even though we have it defined and compiled, to actually run it, we need to invoke it. So I'm just going to define this simple function called run hello world graph. You'll see it defines an initial state that's empty. Again, we don't have an initial state here. More complicated workflows will likely have initial states, which set up some stuff to begin with. And after we set our empty initial state, we just simply call our graph and call invoke, passing our initial state. That will run through the entire graph, running through all the nodes and edges. If it does have to do a breakpoint, it'll break. That's a whole other topic, so we'll get to that later. And then it'll finally log the final state, and we call it. So without further ado, I'm going to save this by just doing Command S or Control S. You can also do File, Save. And now that I have that saved, I can run this npx command, and this should pretty much run this file, which is subsequently going to run this graph. So if I click that greater than underscore, we can see that I ran my graph. So the first thing we'll see is our 3 log messages: step 1, create a greeting; step 2, set recipient; step 3, combine message. And again, that's from these logs within each of our nodes. And then finally, we log the full state, which you can see our greeting has hello, our recipient has world, and the message, as we combined it, has hello, comma, world, exclamation mark. So what we've done now is we've actually created a real graph. We've run through it. It has edges connecting each of the bits. Obviously, there's a lot more complexity, which we'd want to do in order to make this worthwhile. Because if I scroll down, we can see this is the graph that we made. It's very linear. There's no conditional logic. There's no LLMs. Ultimately, if you just wanted to do hello world, you wouldn't need to do this. This is by far overkill. but at least this gets us to the point of knowing how to install it, how to set our basic annotations and our states, how to build our nodes, and also how to create our graphs, connect all those nodes together with edges, and then run them. At this point, I think I'm gonna, let you off to the races and start going through it. Probably only give 15 minutes at this point, just so I can have enough time to, wrap this up. So if anyone does have any questions, please do ask in chat, and I'll try and get to you. But yeah, that's it. So once again, after you finish this hello world, there are 3 main sections and 3 main graphs you're going to go. So there's, quite a lot of content in here. So really, have fun with it and make the most of it. Yep. Thank you. Okay. I'll also, I guess. So yeah, I see a question from Daryl came in that final state format depend on initial state. I believe you can actually, by default, they're the same, but you can customize this. And if you look at the docs, so I don't believe we do it within this project, but you can definitely customize this. I believe you can even customize states kind of within the graph as well. You got to be careful. So for instance, when I've started using subgraphs, so you can, for instance, set a node to be a whole graph in and upon itself, which creates a subgraph. Now this subgraph is going to be defined as well and is going to have its own set of annotations and its own initial/final state as well. Now they do not need to be the same, meaning a subgraph's state annotations can be different from the parent that calls it. However, if you want to share any data between them, they pretty much need to have the same state name. So it gets there's some nuance and it gets a little confusing. But yeah, I do believe that you have, by default, they're the same, but you do have full control over the final and the initial state. So also, I'll go back to the question from, and I apologize if I'm pronouncing this wrong, it's Joveria or Hoveria. And the question is, it is also difficult to understand why the LLM cannot just be improved, forcing users, beginners, and experts alike to use tools like the ones you're mentioning. So I'm not sure if I'm going to answer this correctly, but I will say that LLMs are being improved all the time. So I guess what I'm unsure of the tools that you're talking, if you're talking about the tools like LangGraph. So LangGraph, whether your LLM is, the best in the world, until we get to the point that that LLM can, do everything in itself, we're still going to need to be crafting these workflows somewhat manually. So that being said, it's a very exciting time. I know there's rumors, for instance, about OpenAI coming out with their operator. I don't know if it's a library or API or whatever it might be, where it acts much more agentically, and you can give it a task, it goes off and it does it by itself. There's other tools. There's stuff like Crew AI. You can really dig down deep into this, and I definitely do foresee in the future the models getting better faster. So, do I think in 2 years LangGraph will be, at least in its current form, the way to set up these workflows and to use these LLMs? To be honest, I don't think so. I think things, even if it's called LangGraph, it's probably going to have to change a lot. I see a lot of advancement coming. So, yeah, I'm sorry if I'm not answering your question correctly, or so feel free to be to re-ask it, or to clarify. But yeah, the idea is that the LLMs are getting better, but right now we're still in a point in time where, again, it depends on your problem, but often it makes sense to use really, really cheap and small. And by small, I mean like parameter count models, uh, which again, in general, the less number of parameters uh, that they've trained your model on, uh, the faster and cheaper it's going to be. Uh, and you can, if for instance, if just by going to the IBM's foundation model page and listing all the models we have and looking at all the llamas, the bigger the number is, I believe the 405 billion parameter llama is just a lot more expensive than the cheaper ones. Now this changes over time, but in general, uh, smaller models work faster, and as long as it's good enough, at this point in time, it makes sense to milk these models as much as we can. Meaning, if I can use a bunch of cheaper models and make a more complex workflow, but actually makes my product a lot better, uh, then at least for now, it's definitely worth that investment. And again, it depends completely on what you're trying to do. But for instance, for us, we've definitely done this, and this is both for internal things within my team and other services my team provides. So, yeah. Okay. It's about 15 minutes left, so I'll just start continuing into some uh, final takeaways before opening it up for any final questions. So do feel free if you have any questions to ask them now in chat, and I'll try and get to them. Also, if you do have any other questions, do feel free to reach out on bs@ibm.com. So even if I don't have the answer myself, I can, spit it out to my team and hopefully get the answer to you. So, yeah. So some of the key takeaways I want to get from this presentation and this session is that LLMs have really immense potential as long as you use them effectively and correctly. LangGraph really will empower us as developers to really manage the complexity needed to do really cool stuff with LLMs and to do it with ease. And you really need to code things in such a way that it's very deterministic so that your workflows make sense, work well, and continue to work well, especially as you start adopting new models and tweaking your code and enhancing your graphs and your features. So again, let's not limit ourselves to chatbots. Let's build AI solutions that truly make an impact. Let's really create some cool stuff. So I did have some help from a team member named Boyin. So I just want to give her a big thank you. Again, that's my email, bs@ibm.com, probably one of the easier ones to remember. So again, feel free if you have any questions. And finally, I'll just open the floor up if anyone does have any final questions. Now's the time. We have about 10, 15 minutes. Also, let me briefly, while we see if there are any questions, I will show you this other project. So it is this one. It's called Move to the Best LLM Model for your app. And it's all about choosing the right model. I just put in chat a short link to it. So it's ibm.biz/tx-1166. That'll get you here quickly, but you can also just, from cognitive class, probably just search move, and it should show up at the top. So if I just searched move within cognitive class, and then went down to the guided project section, you'll see it's the first one in the list, move to the best LLM model for your app. And this is a really good introduction to how to really in a very structured way, choose the right model. Again, it uses a tool called Prompt Foo. It's an open source tool. It's very cool. You not only can get the results back from it, it creates nice little visualization, so you can really visualize if you have a lot of models that you want to compare or a lot of different metrics you want to evaluate them on. It's actually quite useful tool. So I definitely would recommend if you're interested. And especially if you're interested in GenAI, to take this move to the best LLM model for your app course, or sorry, guided project. And just as a quick piece of information, this cognitive class, it has courses and projects. Now projects are short or shorter efforts. Generally it's going to be anything from 1 to 3 hours, and you'll actually create something and finish it end to end by the end. Whereas courses are, fully fledged courses. They generally have, 5 different modules, and each module will have instructional content, videos, so on and so forth. And I'll just add that you have access to everything on this platform. Well, most things on this platform are free. There are a couple things which are paid, but for the most part, everything is free and available for you. So again, it's a very good resource. I definitely would recommend you looking around and seeing what's available. But even if you don't want to dig around and look around, this move to the best LLM model is a very good one that I strongly recommend. Just because choosing the right model, again, if you do that wrong, you're kind of setting yourself up for failure. And again, just to repeat it, this is something you really want to do consistently. So you need to have an architecture in place in your code that's going to not just run these tests once, but continuously run them to get the results, and to continuously run them not only on the new models that come out, but also the updates on the old model. So sometimes an update to an old model will actually be they've, rehashed it, they've, retrained it, there's some new data in it. It could mean that they've actually changed the prices. So even though it works exactly the same, it's actually, 10 times cheaper, which maybe means, yes, now we want to use it because the main thing we care about is cost. So yeah, highly recommended. Okay, I see we have a question from Daryl. It says, suppose I'm fine-tuning a foundation model to take AI papers as input, extract abstract and result, and output is a text generated by LLM stating that the result is in line with the abstract or not. How do I get negative samples to fine-tune this model? So first of all, I will say fine-tuning, that's a whole other art uh, as well. So that's pretty much, taking a foundation model, feeding it, a whole bunch of test cases and fine-tuning it. And there's, a variety of different ways to do this. Whether you do it locally yourself, whether you use tools like InstructLab, do it with Hugging Face, so on and so forth. So there's probably ultimately a number of different answers to this question, depending on what you want to do. But here, let's see. Suppose you're fine-tuning your foundation model, take AI papers as input, extract accurate and result. Here's result in line with the abstract or not. How do I get negative samples to fine-tune this model? So I think that'll just be depending on the platform that you really are using to train the model. So for instance, in something called InstructLab, which is a platform for, again, training models, it's really good at training Granite and Llama and some other open source models. What you'll do is you'll pretty much give a lot of examples, and those examples can be pretty much qualified as good or bad within it, and annotated as such. So with that, it's just really annotating the answers as such. But yeah, it really depends on what tool you're using uh, to fine tune your models. So, and again, just for everyone else's sake, this workshop does not cover fine tuning at all. This is simply just using prompting. So pretty much passing all of the instructional information and examples, whether they're positive examples or negative examples, right into that prompt message. So and you can do that in the prompt. So and that's just about choosing. That would be a matter of just choosing the right prompt format, or at the end of the day, write in natural language depending on the model to say, hey, here are examples. Here are examples that are successful. Here are examples that are not successful. And as long as you write this correctly for the model you're using, it should give you good results. So again, just to be very clear, fine tuning a model is taking a model and creating a new model from it, and prompting is just taking one of the existing models and just giving it a whole lot of instructions and trying to get the information back. So that's another choice you need to make. When do I fine tune versus when do I use a foundation model? Now, most of what I find myself personally doing is not fine tuning. Fine tuning can be useful, especially if you have a lot of data. Now, there's other tactics you can use when you have lots of data. So, for instance, you have thousands of papers that you want to ask questions about, or get answers about. You can do fine tuning it based on all those papers, pretty much add those papers and all that papers information into this newly fine tuned model. Or you can use a process like RAG. So pretty much if you're not aware of RAG, it stands for, I believe, Retrieval Augmented Generation. And the idea is what it's going to do is it's first going to go into a database of sorts, and don't take that word for word, I'm being kind of vague, to a database of sorts that has all the information, in this example, all of those papers, and it will kind of find the most relevant bits of pieces, because we can't just take all of them and pass them to the model. That'll overwhelm the context window. we can only, send 128,000 tokens, let's say. And all of these papers is going to be, millions or billions of tokens. So what we do is we pretty much ask this database for the most relevant, let's say, pieces of information out of all the papers, and then take that subset, pass that into the context, that into our prompt instruction. And depending, again, on the problem we want to solve, this could give us, just as good results as, fine tuning the model based on all this information. And, really depends on how you fine tune and how you do it. It could even be better. So the idea, though, how it finds the relevant bits from that, though, is kind of the secret sauce, if you will, of RAG. So it uses vectors. So pretty much it converts all. What you'd want to do is slice up all of those papers into little chunks of information, so little strings of data, and then each of those chunks of strings, which you can imagine it at a very naive level, is just, each sentence in all of the papers will be a different chunk. We just convert that to a vector. So you can just imagine an arrow pointing in some n-dimensional space. And then when we convert all of those and save those to a database, a special vector database. And then the idea is when someone asks a question, it converts that question into a vector as well. And we're able to pretty much query the database, this vector database, based on the vector that we created from whatever question we want to pass in. And it kind of finds the most similar vectors to this question. And effectively what it does is it gives us a good guess at what the most relevant, chunks are. In this case, sentences would be from all of the articles. And then it'll return, the top K results, where you can specify what K is. So give me, the top 10 results, the top 10 sentences, give me the top 1, top 100. It, again, depends on your application. So all in all, I guess it's really important to know that there's lots out there right now. And it isn't necessarily easy to know what the right thing to do is. And it's actually very, very difficult to know what the right thing to do is now and into the future, because things are accelerating really quickly. So if you had to choose, I would definitely err on the side of not fine tuning unless your problem really, really requires it and is not easily solvable with just normal foundation models or something like RAG. Because generally, RAG is going to be a little bit easier, both to code and to maintain into the future. But again, take this with a pinch of salt, because this will change probably tomorrow. I'm sure there's going to be some new model announcements that will throw this all up in the air. Anyways, that being said, there are a few minutes left, but I think I'm not seeing any other questions. So rather than ramble on for another 3 minutes, I'll give everyone a very big thank you. I appreciate everyone for joining. I hope that you all continue taking the workshop and going through the lab and enjoy it. If you have any questions, do please reach out. Also, I guess I will add, within the lab environment, on the left side, if you click the little Ask Ty button, we have our AI teaching assistant. So if you do have any problems, you get an error message, that copy and paste it into Ty. Ty is aware, it uses RAG in the backend, is aware of the lab content and some other stuff, and it can give you some decent help. And if you are still stuck, it can open a support ticket, which will come to me and my team, and we'll help you out. So yeah. So best of luck. Have a wonderful rest of the conference. And yeah, thank you so much for joining, and have a great day.